All right, so hopefully that was enough detail. And now we can move to questions. Guys, like I think the team can come out on stage, and but we really wanted to show the depth and breadth of Tesla in artificial intelligence, compute hardware, robotics actuators, and try to really shift the perception of the company away from, a lot of people think we're like just a car company or we make cool cars, whatever, but they don't have, most people have no idea that Tesla is arguably the leader in real-world AI hardware and software, and that we're building what is arguably the first, the most radical computer architecture since the Cray 1 supercomputer. And I think if you're interested in developing some of the most advanced technology in the world that's going to really affect the world in a positive way, Tesla's the place to be. So yeah, let's fire away with some questions. I think there's a mic at the front and a mic at the back.
Chris,
or
on this side.
Just throw mics at people. Jump ball for the mic.
Yeah. Hi. Thank you very much. I was impressed here. Yeah. I was impressed very much by Optimus, but I wonder why tendon-driven, the hand? Why did you choose a tendon-driven approach for the hand? Because tendons are not very durable. And why spring-loaded?
Yeah. Hello, is this working? Cool, awesome. Yes, that's a great question. When it comes to any type of actuation scheme, there's trade-offs between, whether or not it's a tendon-driven system or some type of linkage-based system.
Just keep the mic close to your mouth.
A little bit closer.
Yeah.
Hear me? Cool.
Yeah.
So yeah, the main reason why we went for a tendon-based system is that, first we actually investigated some synthetic tendons, but we found that metallic Bowden cables are, a lot stronger. One of the advantages of these cables is that it's very good for part reduction. We do want to make a lot of these hands, so having a bunch of parts, a bunch of small linkages ends up being a problem when you're making a lot of something. One of the big reasons that tendons are better than linkages in a sense is that you can be anti-backlash. So anti-backlash essentially, allows you to not have any gaps or, stuttery motion in your fingers. Spring-loaded, mainly what spring-loaded allows us to do is allows us to have active opening. So instead of having to have two actuators to drive the fingers closed and then open, we have the ability to, have the tendon drive them closed and then the springs passively extend. And this is something that's seen in our hands as well, right? We have the ability to actively flex, and then we also have the ability to extend. Yeah.
I mean, our goal with Optimus is to have a robot that is maximally useful as quickly as possible. So there's a lot of ways to solve the various problems of a humanoid robot. We're probably not barking up the right tree on all the technical solutions. And I should say that we're open to evolving the technical solutions that you see here over time. They're not locked in stone. But we have to pick something, and we want to pick something that's going to allow us to produce the robot as quickly as possible and have it, like I said, be useful as quickly as possible. We're trying to follow the goal of fastest path to a useful robot that can be made at volume. And we're going to test the robot internally at Tesla in our factory. And just see how useful is it, because you have to have you got to close the loop on reality to confirm that the robot is in fact useful, yeah. So we're just gonna use it to build things, and we're confident we can do that with the hand that we have currently designed. But for sure there'll be hand version 2, version 3, and we may change the architecture quite significantly over time.
The Optimus robot is really impressive. You did a great job. Bipedal robots are really difficult. But what I noticed might be missing from your plan is to acknowledge the utility of the human spirit, and I'm wondering if Optimus will ever get a personality and be able to laugh at our jokes while it folds our clothes.
Yeah, absolutely. I think we want to have really fun versions of Optimus, and so that Optimus can both be utilitarian and do tasks, but can also be kind of like a friend and a buddy and hang out with you. And I'm sure people will think of all sorts of creative uses for this robot. The thing, once you have the core intelligence and actuators figured out, then you can actually, put all sorts of costumes, I guess, on the robot. I mean, you can make the robot look. You can skin the robot in many different ways, I'm sure people will find very interesting ways to versions of Optimus. So.
Thanks for the great presentation. I wanted to know if there was an equivalent to interventions in Optimus. It seems like labeling through moments where humans disagree with what's going on is important, and in a humanoid robot, that might be also a desirable source of information.
Want to say anything?
Yeah, I think we'll have ways to remote operate the robot and intervene when it does something bad, especially when we are training the robot and bringing it up. And hopefully we design it in a way that we can stop the robot from, if it's going to hit something, we can just like hold it and then it'll stop. It won't crush your hand or something. And those are all intervention data. And we can learn a lot from our simulation systems too, where we can check for collisions and supervise that those are bad actions.
Yeah, I mean, so Optimus, we want over time for it to be, an android, the kind of android that you'd seen in sci-fi movies, like Star Trek: The Next Generation, like Data. But obviously, we could program the robot to be less robot-like and more friendly, and it can obviously learn to emulate humans and feel very natural. So as AI in general improves, we can add that to the robot, and it should be obviously able to do simple instructions or even intuit what it is that you want. So you could give it a high-level instruction, and then it can break that down into a series of actions and take those actions.
Hi. Yeah, it's exciting to think that with the Optimus, you will think that you can achieve orders of magnitude of improvement in economic output. That's really exciting. And when Tesla started, the mission was to accelerate the advent of renewable energy or sustainable transport. So with the Optimus, do you still see that mission being the mission statement of Tesla, or is it going to be updated with, mission to accelerate the advent of, I don't know, infinite abundance or limitless economy?
Yeah, it is not strictly speaking, Optimus is not strictly speaking directly in line with accelerating sustainable energy. To the degree that it is more efficient at getting things done than a person, it does, I guess, help with sustainable energy. But I think the mission effectively does somewhat broaden with the advent of Optimus to I don't know, making the future awesome. So, I think you look at Optimus, and I don't know about you, but I'm excited to see what Optimus will become. And, this is like, if you could, we can tell, like any given technology, do you want to see what it's like in a year, 2 years, 3 years, 4 years, 5 years, 10? I'd say for sure. You definitely want to see what's happening with Optimus. Whereas, a bunch of other technologies are, sort of plateaued. Won't name names here, but so I think Optimus is going to be incredible in like 5 years, 10 years, like mind-blowing. And I'm really interested to see that happen, and I hope you are too.
I have a quick question here. I'm Justin, and I was wondering, like, are you planning to extend like conversational capabilities for the robot? And my second follow-up question to that is, what's like the end goal? What's the end goal with Optimus?
Yeah, Optimus would definitely have conversational capabilities. You'd be able to talk to it and have a conversation, and it would feel quite natural. So, from an end goal standpoint, I don't know. I think it's going to keep evolving, and I'm not sure where it ends up, but someplace interesting for sure. We always have to be careful about don't go down the Terminator path. That's I thought maybe we should start off with a video of like the Terminator starting off with this, skull crushing, but that might be, people might take that too seriously. So, we do want Optimus to be safe, so we are designing in safeguards where you can locally stop the robot, with like basically a localized control ROM that you can't update over the internet, which I think that's quite important, essential, frankly. Like a localized stop button, remote control, something like that cannot be changed. But I mean, it's definitely going to be interesting. It won't be boring.
Okay, yeah. I see you today. You have very attractive product with Dojo and its applications. So I'm wondering, what's the future for the Dojo platform? Will you provide infrastructure as service like AWS, or you will sell the chip like the NVIDIA? So basically, what's the future? Because I see you use 7 nanometer, so the development cost is easily over $10 million US dollars. How do you make the business business-wise?
Yeah, I mean, Dojo is a very big computer, and actually will use a lot of power and need a lot of cooling. So I think it's probably going to make more sense to have Dojo operate in like a Amazon Web Services manner than to try to sell it to someone else. So that would be the most efficient way to operate Dojo, is just have it be a service that you can use that's available online, and that where you can train your models way faster and for less money. And as the world transitions to software 2.0,
and that's on the bingo card.
as someone I know has to now drink 5 tequilas. Let's see. Software 2.0
Yeah.
will use a lot of neural net training. So, it kind of makes sense that over time, as there's more neural net stuff, people will want to use the fastest, lowest cost neural net training system. So I think there's a lot of opportunity in that direction.
Hi, my name is Ali Jahanian. Thank you for this event. It's very inspirational. My question is, I'm wondering, what is your vision for humanoid robots that understand our emotions and art and can contribute to our creativity?
Well, I think you're already seeing robots that at least are able to generate very interesting art with like DALL-E and DALL-E 2. And I think we'll start seeing AI that can actually generate even movies that have coherence, like interesting movies and tell jokes. So it's quite remarkable how fast AI is advancing at many companies besides Tesla. We're headed for a very interesting future. And so you guys want to comment on that?
Yeah, I guess the Optimus robot can come up with physical art, not just digital art. You can ask for some dance moves in text or voice, and then you can like, produce those in the future. So it's a lot of like physical art, not just digital art.
Oh, yeah. Computers can absolutely make physical art. Yeah.
Yeah.
100%.
Yeah, like dance,
Sure.
play soccer, or whatever
Yeah.
you. I mean, it needs to get more agile, but over time, for sure.
Thanks so much for the presentation. For the Tesla Autopilot slides, I noticed that the models that you were using were heavily motivated by language models. And I was wondering what the history of that was and how much of an improvement it gave. I thought that was a really interesting, curious choice to use language models for the lane transitioning.
So there's sort of two aspects for why we transition to language modeling. So the first...
Talk loud and close.
Okay.
It's not coming through very clearly.
Okay, got it. Yeah, so the language models help us in two ways. The first way is that it lets us predict lanes that we couldn't have otherwise. As Ashok mentioned earlier, basically when we predicted lanes in sort of a dense 3D fashion, you can only model certain kinds of lanes, but we want to get those crisscrossing connections inside of intersections. It's just not possible to do that without making it a graph prediction. If you try to do this with dense segmentation, it just doesn't work. Also, the lane prediction is a multimodal problem. Sometimes you just don't have sufficient visual information to know precisely how things look on the other side of the intersection. So you need a method that can generalize and produce coherent predictions. You don't want to be predicting 2 lanes and 3 lanes at the same time. You want to commit to one, and a generative model like these language models provides that.
Hi. My name is Giovanni. Yeah, thanks for the presentation. It's really nice. I have a question for FSD team. So for the neural networks, how do you test, how do you do unit tests, software unit tests on that? Like, do you have like a bunch, or I don't know, maybe thousands or cases where the neural network that after you train it, you have to pass it before you release it as a product, right? What's your software unit testing strategies for this, basically?
Yeah, glad you asked. There's like a series of tests that we have defined, starting from unit tests for the software itself, but then for the neural network models, we have VIP sets defined where you can define. If you just have a large test set, that's not enough. What we find, we need like sophisticated VIP sets for different failure modes, and then we curate them and grow them over the time of the product. So over the years, we have like hundreds of thousands of examples where we have been failing in the past that we have curated. And so for any new model, we test against the entire history of these failures and then keep adding to this test set. On top of this, we have shadow modes where we ship these models in silent to the car, and we get data back on where they are failing or succeeding. And there's an extensive QA program. It's very hard to ship a regression. There's like 9 levels of filters before it hits customers, but then we have really good infra to make this all efficient.
And I'm one of the QA testers, so I QA the car.
Yeah,
like
QA tester.
Yeah, so I'm constantly in the car just being QAing like whatever the latest alpha build is that doesn't totally crash.
Yeah. Finds a lot of bugs.
Yeah.
Hi, great event. I have a question about foundational models for autonomous driving. We have all seen that big models that really can, when you scale up with data and model parameter, right, from GPT-3 to PaLM, it can actually now do reasoning. Do you see that is essential scaling up foundational models with data and size, and then at least you can get a teacher model, right, that potentially can solve all the problems, and then you distill to a student model. Is that how you see foundational models relevant for autonomous driving?
That's quite similar to our auto labeling model. So we don't just have models that run in the car. We train models that are entirely offline, that are like extremely large, that can't run in real time on the car. So we just run those offline on the servers, producing really good labels that can then train the online networks. So that's one form of distillation of these teacher-student models. In terms of foundation models, we are building some really, really large data sets that are multiple petabytes. And we are seeing that some of these tasks work really well when we have these large data sets. Like the kinematics, like I mentioned, video in, all the kinematics out of all the objects. and up to the fourth derivative. And people thought we couldn't do detection with cameras. I mean, detection, depth, velocity, acceleration. And imagine how precise these have to be for these higher order derivatives to be accurate. And this all comes from these kind of large data sets and large models. So we're seeing the equivalent of foundation models in our own way for geometry and kinematics and things like those. Do you want to add anything, John?
Yeah, I'll keep it brief. Basically, whenever we train on a larger data set, we see okay. Basically, whenever we train on a larger data set, we see big improvements in our model performance. And basically, whenever we initialize our networks with some pre-training step from some other auxiliary task, we basically see improvements. The self-supervised or supervised with large data sets both help a lot.
Hi. So at the beginning, Elon said that Tesla was potentially interested in building artificial general intelligence systems. Given the potentially transformative impact of a technology like that, it seems prudent to invest in technical AGI safety expertise specifically. I know Tesla does a lot of technical narrow AI safety research. I was curious if Tesla was intending to try to build expertise in technical artificial general intelligence safety specifically.
Well, if it starts looking like we're going to be making a significant contribution to artificial general intelligence, then we'll for sure invest in safety. I'm a big believer in AI safety. I think there should be an AI sort of regulatory authority at the government level, just as there is a regulatory authority for anything that affects public safety. So we have a regulatory authority for aircraft and cars and sort of food and drugs. And because they affect public safety, and AI also affects public safety. So I think, and this is not really something that government, I think, understands yet, but I think there should be a referee that is ensuring or trying to ensure public safety for AGI. And if you think of what are the elements that are necessary to create AGI? The accessible data set is extremely important, and if you've got a large number of cars and humanoid robots processing petabytes of video data and audio data from the real world, just like humans, that might be the biggest data set. It probably is the biggest data set. Because in addition to that, you can obviously incrementally scan the internet. But what the internet can't quite do is have millions or hundreds of millions of cameras in the real world, and with like I said, with audio and other sensors as well. So I think we probably will have the most amount of data, and probably the most amount of training power. Therefore, probably we will make a contribution to AGI.
Hey, I noticed the semi was back there, but we haven't talked about it too much. I was just wondering, for the semi-truck, what are the changes you're thinking about from a sensing perspective? I imagine there's very different requirements, obviously, than just a car. And if you don't think that's true, why is that true?
No, I think basically you can drive a car. I mean, think about what drives any vehicle. It's a biological neural net with eyes, with cameras, essentially. So if and really, what is your primary sensors are two cameras on a slow gimbal, a very slow gimbal. That's your head. So if a biological neural net with two cameras on a slow gimbal can drive a semi-truck, then if you've got like 8 cameras with continuous 360-degree vision, operating at a higher frame rate and much higher reaction rate, then I think it is obvious that you should be able to drive a semi or any vehicle much better than a human.
Hi, my name is Akshay. Thank you for the event. Assuming Optimus would be used for different use cases and would evolve at different pace for these use cases, would it be possible to sort of develop and deploy different software and hardware components independently and deploy them in Optimus, so that the overall feature development is faster for Optimus?
All right, we did not comprehend. Unfortunately, our neural net did not comprehend the question. Yeah, so, well, next question.
Hi, I want to switch the gear to the autopilot. So when you guys plan to roll out the FSD beta to countries other than US and Canada? And also my next question is, what's the biggest bottleneck or the technological barrier you think in the current autopilot stack? And how you envision to solve that to make the autopilot is considerably better than human in terms of like performance matrix like safety assurance and the human confidence? And I think you also mentioned for FSD V11, you are guys going to combine the highway and the city as a single stack and some architectural big improvement. Can you maybe expand a bit on that? Thank you.
Well, that's a whole bunch of questions. Well, we're hopeful to be able to, I think from a technical standpoint, FSD beta should be possible to roll out FSD beta worldwide by the end of this year. But for a lot of countries, we need regulatory approval, and so we are somewhat gated by the regulatory approval in other countries. But I think from a technical standpoint, it will be ready to go to a worldwide beta by the end of this year. And there's quite a big improvement that we're expecting to release next month. That will be especially good at assessing the velocity of fast-moving cross traffic and a bunch of other things. So, anyone want to elaborate?
Yeah, I guess so. There used to be a lot of differences between production autopilot and the full self-driving beta, but those differences have been getting smaller and smaller over time. I think just a few months ago, we now use the same vision-only object detection stack in both FSD and in the production autopilot on all vehicles. There's still a few differences, the primary one being the way that we predict lanes right now. So we upgraded the modeling of lanes so that it could handle these more complex geometries like I mentioned in the talk. In production autopilot, we still use a simpler lane model, but we're extending our current FSD beta models to work in all sort of highway scenarios as well.
Yeah, and the version of FSD beta that I drive actually does have the integrated stack. So it uses the FSD stack both in city streets and highway, and it works quite well for me. But we need to validate it in all kinds of weather, like heavy rain, snow, dust, and just make sure it's working better than the production stack across a wide range of environments. But we're pretty close to that. I mean, I think it's, I don't know, maybe, it'll definitely be before the end of the year, and maybe November.
Yeah, in our personal drives, the FSD stack on highway drives already way better than the production stack we have. And we do expect to also include the parking lot stack as a part of the FSD stack before the end of this year. So that will basically bring us to, you sit in the car in the parking lot and drive till the end of the parking lot at a parking spot before the end of this year.
Yeah, and in terms of the fundamental metric to optimize against is how many miles between a necessary intervention. So just massively improving how many miles the car can drive in full autonomy before an intervention is required that is safety critical. So yeah, that's the fundamental metric that we're measuring every week, and we're making radical improvements on that.
Oh, hi. Thank you. Hi. Thank you so much for the presentation. Very inspiring. My name is Daisy. I actually have a non-technical question for you. I'm curious, if you were back to your 20s, what are some of the things you wish you knew back then? What are some advice you would give to your younger self?
Well, I'm trying to figure out something useful to say. Yeah, join Tesla would be one thing. Yeah, I think just try to expose yourself to as many smart people as possible. I don't know, read a lot of books, you know, that did do that though. I think there's some merit to just also like not being like necessarily too intense and like enjoying the moment a bit more. I would say to 20 or 20-something me, just you know, stop and smell the roses occasionally would probably be a good idea. You know, it's like when we were developing the Falcon 1 rocket and on the Kwajalein Atoll, and we had this beautiful little island that we're developing the rocket on, and not once during that entire time did I even have a drink on the beach. I'm like, well, I should have had a drink on the beach. That would have been fine.
Thank you very much. I think you have excited all of the robotics people with Optimus. This feels very much like 10 years ago in driving, but as driving has proved to be harder than it actually looked 10 years ago, what do we know now that we didn't 10 years ago that would make, for example, AGI on a humanoid come faster?
Well, I mean, it seems to me that AGI is advancing very quickly. Hardly a week goes by without some significant announcement. And yeah, I mean, at this point, like AI seems to be able to win at almost any rule-based game. It's able to create extremely impressive art, engage in conversations that are very sophisticated, you know, write essays, and these just keep improving. And there's so much more, so many more talented people working on AI, and the hardware is getting better. I think AI is on a strong exponential curve of improvement, independent of what we do at Tesla. And obviously, we'll benefit somewhat from that exponential curve of improvement with AI. Like Tesla just also happens to be very good at actuators, at motors, you know, motors, gearboxes, controllers, power electronics, batteries, sensors, and you know, really, like I'd say that you know the biggest difference between the robot on 4 wheels and the robot with arms and legs is getting the actuators right. It's an actuators and sensors problem. And obviously, you know, how you control those actuators and sensors, but it's yeah, actuators and sensors and how you control the actuators. It's I don't know. We have to have like the ingredients necessary to create a compelling robot, and we're doing it. So.
Hi, Elon. You are actually bringing the humanity to the next level. Literally, Tesla and you are bringing the humanity to the next level. So you said Optimus Prime, Optimus will be used in next Tesla factory. My question is, will a new Tesla factory will be fully run by Optimus program? And when can general public order a humanoid?
Yeah, I think it'll, you know, we're going to start Optimus with very simple tasks in the factory. You know, like maybe just like loading a part, like you saw in the video, loading a part, you know, carrying a part from one place to another, or loading a part into one of our more conventional robot cells to, you know, that welds the body together. So we'll start, you know, just trying to, how do we make it useful at all? And then gradually expand the number of situations where it's useful. And I think that the number of situations where Optimus is useful will grow exponentially, like really, really fast. In terms of when people can order one, I don't know. I think it's not that far away. Well, I think you mean when can people receive one? So I don't know. I'd say probably within 3 years, and not more than 5 years. Within 3 to 5 years, you could probably receive an Optimus.
I feel the best way to make the progress for AGI is to involve as many smart people across the world as possible.
And given the size and resource of Tesla compared to robot companies, and given the state of humanoid research at the moment, would it make sense for the kind of Tesla to sort of open source some of the simulation hardware parts? I think Tesla can still be the dominant platformer where it can be something like Android OS or like iOS stuff for the entire humanoid research. Would that be something that, rather than keeping the Optimus to just Tesla researchers or the factory itself, can you open it and let the whole world explore humanoid research?
I think we have to be careful about Optimus being potentially used in ways that are bad, because that is one of the possible things to do. So I think we'd provide Optimus where you can provide instructions to Optimus, but where those instructions are governed by some laws of robotics that you cannot overcome. So, not doing harm to others, and you would have, I think, probably quite a few safety-related things with Optimus. Yeah. So, all right, we'll just take maybe a few more questions, and then thank you all for coming.
Questions, one deep and one broad. On the deep, for Optimus, what's the current and what's the ideal controller bandwidth? And then in the broader question, there's this big advertisement for the depth and breadth of the company. What is it uniquely about Tesla that enables that?
Anyone want to tackle the bandwidth question?
Yeah. So the technical bandwidth of the...
Close to your mouth and loud.
Okay. For the bandwidth question, you have to understand or figure out what is the task that you want it to do, and what is the if you took a frequency transform of that task, what is it that you want your limbs to do? And that's where you get your bandwidth from. It's not a number that you can specifically just say. You need to understand your use case, and that's where the bandwidth comes from. What is the broad question? I don't quite remember.
The breadth and depth thing. I can answer the breadth and depth, but yeah. I mean, it's interesting. On the bandwidth question, I think we probably will just end up increasing the bandwidth, or which translates to the effective dexterity and reaction time of the robot. It's safe to say it's not 1 hertz, and it's maybe you don't need to go all the way to 100 hertz, but I don't know, maybe 10, 25, I don't know. Over time, I think the bandwidth will increase quite a bit, or translated to dexterity and latency. You'd want to minimize that over time. Minimize latency, maximize dexterity. I mean, in terms of breadth and depth, I guess we're a pretty big company at this point, so we've got a lot of different areas of expertise that we necessarily had to develop in order to make autonomous, or in order to make electric cars, and then in order to make autonomous electric cars. Tesla is like a whole series of startups, basically, and so far they've almost all been quite successful. So we must be doing something right. I consider one of my core responsibilities in running the company is to have an environment where great engineers can flourish. And I think in a lot of companies, I don't know, maybe most companies, if somebody's a really talented, driven engineer, they're unable to actually, their talents are suppressed at a lot of companies. And it's, and some of the companies, the engineering talent is suppressed in a way that is maybe not obviously bad, but where it's just so comfortable, and you're paid so much money, and the output you actually have to produce is so low that it's like a honey trap, So like there's a few honey trap places in Silicon Valley where they're not necessarily, don't seem like bad places for engineers, but you have to say like a good engineer went in, and what did they get out? And the output of that engineering talent seems very low. even though they seem to be enjoying themselves. That's why I call it, there's a few honey trap companies in Silicon Valley. Tesla is not a honey trap. We're demanding, and it's like, we're going to get a lot of shit done, and it's going to be really cool. And it's not going to be easy. But if you are a super talented engineer, your talents will be used, I think, to a greater degree than anywhere else. SpaceX also that way. So.
Hi, Elon. I have two questions. So both to the Autopilot team. So the thing is, like, I have been following your progress for the past few years. So today you have made changes on like the lane detection. Like you said that like previously you were doing instance semantic segmentation. Now you guys have built transform models for like building the lanes. So what are some other common challenges which you guys are facing right now, like which you are solving in future as a curious engineer, so that like we as a researcher can work on those, start working on those? And the second question is like I'm really curious about the data engine. Like you guys have like told a case like where the car is stopped. So how are you finding cases which is very much similar to that from the data which you have? Like so, little bit more on the data engine would be great. So that's it.
Okay. I'll answer the first question using occupancy network as an example. So what you saw in the presentation did not exist a year ago. So we only spent 1 year amount of time. We actually shipped more than 12 occupancy network. And to have one foundation model actually to represent the entire physical world around everywhere and in all weather conditions is actually really, really challenging. So only over a year ago, we're kind of like driving a 2D world. If there's a wall and if there's a curve, we kind of represent with the same static edge, which is obviously not ideal, right? There's a big difference between a curve and a wall. When you drive, you make different choices, right? So after we realized that we have to go to 3D, we have to basically rethink the entire problem and think about how we address that. So this will be like one example of challenges we have conquered in the past year.
Yeah, to answer the question about how we actually source examples of the tricky stopped cars, there's a few ways to go about this, but two examples are one, we can trigger for disagreements within our signals. So let's say that parked bit flickers between parked and driving, we'll trigger that back. And the second is we can leverage more of the shadow mode logic. So if the customer ignores the car, but we think we should stop for it, we'll get that data back too. So these are just different, like various trigger logic that allows us to get those data campaigns back.
Hi.
Sorry, go ahead.
Thank you for the amazing presentation. Thanks so much. So there are a lot of companies that are focusing on the AGI problem. And one of the reasons why it's such a hard problem is because the problem itself is so hard to define. Several companies have several different definitions. They focus on different things. So what is Tesla, how is Tesla defining the AGI problem, and what are you focusing on specifically?
Well, we're not actually specifically focused on AGI. I'm simply saying that AGI seems likely to be an emergent property of what we're doing. Because we're creating all these autonomous cars and autonomous humanoids that are actually with a truly gigantic data stream that's coming in and being processed. It's by far the most amount of real-world data, and data you can't get by just searching the internet, because you have to be out there in the world and interacting with people and interacting with the roads and just, Earth is a big place, and reality is messy and complicated. So I think it's sort of like it just seems likely to be an emergent property of if you've got tens or hundreds of millions of autonomous vehicles and maybe even a comparable number of humanoids, maybe more than that on the humanoid front. Well, that's just the most amount of data. And if that video is being processed, it just seems likely that the cars will definitely get way better than human drivers, and the humanoid robots will become increasingly indistinguishable from humans, perhaps. And so then, like I said, you have this emergent property of AGI. and arguably, humans collectively are sort of a super intelligence as well, especially as we improve the data rate between humans. I mean, the thing like that seemed to me way back in the early days of the internet was like the internet was like humanity acquiring a nervous system where now all of a sudden any one element of humanity could know all of the knowledge of humans by connecting to the internet, almost all the knowledge, or certainly a huge part of it, whereas previously we would exchange information by osmosis, we'd have to, like, in order to transfer data, so you would have to write a letter, someone would have to carry the letter by person to another person, and then a whole bunch of things in between, and then it was like, yeah, I mean, insanely slow when you think about it. And even if you were in the Library of Congress, you still didn't have access to all the world's information, and you certainly couldn't search it. And obviously, very few people are in the Library of Congress. So, I mean, one of the great sort of equality elements, like the internet has been the biggest equalizer in history in terms of access to information and knowledge. And any student of history, I think, would agree with this, because you go back 1,000 years, there were very few books, and books would be incredibly expensive, and only a few people knew how to read, and only an even smaller number of people even had a book. Now look at it, like you can access any book instantly. You can learn anything basically for free. It's pretty incredible. So, I was asked recently, what period of history would I prefer to be at the most? And my answer was right now. This is the most interesting time in history, and I read a lot of history. So let's do our best to keep that going. Yeah. And to go back to one of the earlier questions I would answer, like the thing that's happened over time with respect to Tesla Autopilot is that the neural nets have gradually absorbed more and more software. And in the limit, of course, you could simply take the videos as seen by the car and compare those to the steering inputs from the steering wheel and pedals, which are very simple inputs. In principle, you could train with nothing in between, because that's what humans are doing with a biological neural net. You could train based on video, and what trains the video is the moving of the steering wheel and the pedals, with no other software in between. We're not there yet, but it's gradually going in that direction. All right, well, maybe one last question.
How you going?
I think we've got a question at the front here. Hello, there, right there. Oh, we'll do 2 questions, fine.
Over there or here?
Hi, thanks for such a great presentation.
We'll do your question last.
Okay, cool. With FSD being used by so many people, do you think, how do you evaluate the company's risk tolerance in terms of performance statistics? And do you think there needs to be more transparency or regulation from third parties as to what's good enough and defining like thresholds for performance across so many miles?
Sure. Well, the number one design requirement at Tesla is safety. So, and that goes across the board. So, in terms of the mechanical safety of the car, we have the lowest probability of injury of any cars ever tested by the government for just a passive mechanical safety, essentially crash structure and airbags and whatnot. We have the best, the highest rating for active safety as well. And I think it's going to get to the point where the active safety is so ridiculously good, it's like just absurdly better than a human. And then with respect to autopilot, we do publish this, broadly speaking, the statistics on miles driven with cars that have no autonomy, or Tesla cars with no autonomy, with kind of hardware 1, hardware 2, hardware 3, and then the ones that are in FSD beta. And we see steady improvements all along the way. And sometimes there's this dichotomy of, should you wait until the car is like, I don't know, 3 times safer than a person before deploying any technology? But I think that is actually morally wrong. At the point at which you believe that that adding autonomy reduces injury and death, I think you have a moral obligation to deploy it, even though you're going to get sued and blamed by a lot of people, because the people whose lives you saved don't know that their lives are saved, and the people who do occasionally die or get injured, they definitely know, or their estate does, that it was, whatever, there was a problem with autopilot. That's why you have to look at the numbers in sort of total miles driven, how many accidents occurred, how many accidents were serious, how many fatalities. And we've got well over 3 million cars on the road, so that's a lot of miles driven every day. It's not going to be perfect, but what matters is that it is very clearly safer than not deploying it. Yeah. So I think last question. I think, yeah, so thanks. Well, the last question here.
Okay. Okay. Hi. So I do not work on hardware, so maybe the hardware team and you guys can enlighten me. Why is it required that there be symmetry in the design of Optimus? Because humans, we have handedness, right? We use some set of muscles more than others. Over time, there is wear and tear, right? So maybe you'll start to see some joint failures or some actuator failures more over time. I understand that this is extremely pre-stage. Also, we as humans have based so much fantasy and fiction over superhuman capabilities. Like all of us don't want to walk right over there. We want to extend our arms, and like we have all these,
Sure.
A lot of fantastical designs. So considering everything else that is going on in terms of batteries and intensity of compute, maybe you can leverage all those aspects into coming up with something, well, I don't know, more interesting in terms of the robot that you're building. And I'm hoping you're able to explore those directions.
Yeah, I think it would be cool to have, like, make Inspector Gadget real. That would be pretty sweet. So, yeah, I mean, right now we just want to make a basic humanoid work well, and our goal is fastest path to a useful humanoid robot. I think this will ground us in reality, literally, and ensure that we are doing something useful. Like, one of the hardest things to do is to be useful. To actually, and then to have high utility under the curve of, like, how many people did you help, and how much help did you provide to each person on average, and then how many people did you help? The total utility, like trying to actually ship useful product that people like to a large number of people is so insanely hard. It boggles the mind. That's why, like I said, like, man, there's a hell of a difference between a company that has shipped product and one that has not shipped product. This is night and day. And then even once you ship product, can you make the value of the output worth more than the cost of the input, which is, again, insanely difficult, especially with hardware. So, but I think over time, I think it would be cool to do creative things and have like 8 arms and whatever, and have different versions, and maybe, there'll be some hardware, like companies that are able to add things to an Optimus. Like maybe we add a power port or something like that, or attach them. You can add attachments to your Optimus, like you can add them to your phone. There could be a lot of cool things that could be done over time, and there could be maybe an ecosystem of small companies or big companies that make add-ons for Optimus. So with that, I'd like to thank the team for their hard work. You guys are awesome, and thank you all for coming, and for everyone online, thanks for tuning in. And I think this will be one of those great videos where you can, like, if you can fast forward to the bits that you find most interesting. But we try to give you a tremendous amount of detail, literally, so that you can look at the video at your leisure, and you can focus on the parts that you find interesting and skip the other parts. So thank you all, and we'll do this. Try to do this every year, and we might do a monthly podcast even. But I think it'd be great to sort of bring you along for the ride and like show you what cool things are happening. And yeah, thank you. All right, thanks.